Put a piece of raw meat in your mouth, not rare. Raw, cold, wet, rubbery, stringy with sinew, fighting your teeth with every chew. You'd gnaw at it for a minute and give up, jaw aching, having swallowed almost nothing. Now imagine that's dinner, every night, for 2 million years, because for almost the entire time humans have existed, there was no fire, no cooking, no warm food, no soft food, nothing heated, ever. Just your ancestors, a mouthful of surprisingly weak teeth, and a whole world that had to be eaten cold and raw. Or not at all. And here's the part that should stop you. You are not built for that, not even slightly. Look at your teeth in the mirror. They're pathetic. Your jaw is weak. Your gut is short. By the standards of an animal that eats raw food, your entire body is broken. So how did a creature this badly equipped survive millions of years eating nothing but raw? The answer rebuilt your face, your teeth, and your brain so completely that you couldn't go back even if you tried. Let's start with what was actually on the menu. Go back 3 to 4 million years to the Australopithecines, the group that includes Lucy, the famous skeleton found in Ethiopia. These were early members of our lineage, living on the African savanna, and they ate roughly what you'd expect: fruit, leaves, seeds, tubers dug from the ground, insects, and occasionally meat, but not the way you eat meat. Picture it. A lion makes a kill and eats its fill. It wanders off, and now there's a narrow, terrifying window where a small, weak, upright ape can rush in and tear off whatever it can before the hyenas arrive. No cooking, no preparation, raw flesh, ripped from a carcass with hands and teeth, swallowed as fast as possible in a race against everything else on the savanna that also wanted it. We know they ate like this because their teeth remember it. The chemistry of what an animal eats gets locked into its tooth enamel and stays there for millions of years. Read it back, and the Australopithecines tell you something clear. They were not fussy. They ate whatever the season gave them, whatever they could find, catch, or steal before something bigger stole it back. But raw food comes with a brutal cost, and that cost is written all over your ancestors' bodies. Raw plants are extraordinarily hard to digest. The tough structural fiber in a plant, cellulose, is essentially locked. Your body can barely get into it without cooking or long fermentation. Take a raw tuber, basically a wild potato, one of the most reliable, calorie-rich foods on the ancient landscape. Eaten raw, your body extracts only about 40% of the calories inside it. The rest passes straight through you, untouched. You do all the work of eating it and get less than half the reward. So how do you survive on food that fights you like that? You grow a bigger machine to process it. The Australopithecines had enormous guts for their body size. And a gut is not free. It's one of the most energy-hungry tissues you own, burning fuel around the clock just to exist. A huge gut is the unmistakable signature of an animal forced to shovel through vast amounts of low-quality raw food just to scrape together enough calories to live. You can watch this today. A chimpanzee eats mostly raw fruit and leaves, and its gut is about 3 times larger than yours relative to body size. And it chews. It chews for 6 to 8 hours a day. That's not a figure of speech. A chimp spends most of its waking life with something in its mouth, grinding, because raw food demands it. Now compare that to you. Your jaw muscles are dramatically weaker than a chimp's. Your teeth are far smaller. Your intestines are far shorter. These aren't small differences. They're the fingerprints of an animal that, somewhere in its past, stopped needing to grind through mountains of raw food. Something took that job away from your body. The question of what and when is one of the biggest in the entire story of human evolution. The man who spent his life answering it is a Harvard scientist named Richard Wrangham, and his answer flips everything you'd assume. We tend to think cooking is something humans invented once they were already smart. Wrangham argues it's the other way around. Cooking didn't come after we became human. Cooking is what made us human. Here's the logic, and it's beautiful. Cooking does for free what your gut was straining to do. It breaks food down before it reaches your mouth. Fire unlocks the calories that raw tubers and raw meat keep sealed. Suddenly, you don't need the giant gut. You don't need the massive jaw. You don't need to chew for 8 hours. And all that energy, the huge budget your body was spending on processing raw food, is freed up and redirected to the one organ that makes us, the brain. Your brain is the single most expensive organ in the known animal kingdom. It's 2% of your body weight and eats 20% of your energy, a fifth of every calorie just sitting there thinking. And here's the thing, you cannot build a brain like that on raw food. There isn't enough spare energy, not while your body's pouring its fuel into a giant digestive system running day and night. Something had to give. What gave was the raw food diet. Cooking created a surplus of calories so large that it could pay for a bigger brain. And the brain expanded and kept expanding until it left every other primate on Earth far behind. Clean story. Except, there's a problem, a huge one, and real scientists argue about it to this day. The oldest solid evidence of controlled fire we've dug up is about 1 million years old, but the human brain starts its dramatic growth spurt way earlier than that, with Homo erectus, around 1.8 million years ago. That's a gap of roughly 800,000 years. The brain starts ballooning nearly 1 million years before we have clear proof anyone was cooking. So the cooking hypothesis smacks straight into one question it struggles to answer. If fire wasn't there yet, what were they eating in the meantime? There are a few answers, and the honest truth is none of them fully satisfies, which tells you how live this debate still is. Maybe fire is just older than the evidence we found. A single campfire on a riverbank used once might leave nothing behind for us to dig up 1 million years later. Absence of evidence isn't evidence of absence. The gap might be a hole in the record, not in the behavior. Or maybe they were processing food without full cooking, pounding it, slicing it with stone tools, mashing tubers, tenderizing raw meat by smashing it, breaking food down mechanically, outside the body, getting some of the benefit of cooking before cooking existed. Not the full payoff, but maybe enough to start feeding a growing brain. And once again, the teeth know things the rest of the skeleton doesn't. Under an electron microscope, the surface of a fossil tooth is covered in microscopic scratches and pits, and they're a record of texture. Hard foods like nuts leave little pits. Tough, fibrous raw meat and leaves leave long parallel scratches. Soft, processed, cooked food leaves the surface relatively smooth. Look at the teeth of early Homo erectus, and they show a diet of noticeably softer food than the Australopithecines before them. Not proof of fire, but exactly what you'd expect if food was being softened, one way or another, before it was eaten. And then there's the face. This is the part I want you to actually feel. Pull up a reconstruction of Homo erectus and look at it next to your own reflection. The heavy brow is already shrinking. The teeth are already getting smaller. The big protruding jaw is already pulling back. The skull is rounding out, swelling, making room for a brain that's growing faster than anything in primate history. You are watching, in bone, an animal handing the job of chewing over to technology, to stone tools, to fire, to transforming food before it goes in the mouth instead of after. The face is shrinking because it doesn't have to fight food anymore, and that face never stops shrinking. It leads directly to yours. Your face is smaller than your ancestors. Your jaw is weaker. Your teeth are tiny next to the apes you share a bloodline with. You can't efficiently eat raw tubers. You can't digest raw grains at all. In the most literal, physical sense, you are a cooked food animal. Cooking didn't just change your meals. It built your body over 2 million years so thoroughly that going fully raw isn't returning to some natural state. It's an experiment your digestive system genuinely can't pass. People who try to live entirely on raw food often struggle to keep weight on because the brain in your skull demands more fuel than raw food can hand over. But the deepest change cooking made wasn't your teeth or your gut or even your brain. It was your time. A chimp spends half its waking life eating, half, because raw food demands it. Cooking concentrates calories so efficiently that the time you need to feed yourself collapses. Modern hunter-gatherers, cooking their food, spend a fraction of what a chimp does. Think about what that means. Cooking didn't just feed the brain, it freed the hours. All those hours that used to be swallowed by endless chewing suddenly opened up. Hours for making tools, for talking, for teaching children, for telling stories, for all the non-urgent, creative human things that an animal living on the raw food edge can never afford. And the fire that cooked the food was the same fire everyone gathered around afterwards. The same circle of light where the stories got told and the culture got built. The diet and the civilization were never two separate stories. They're one story. Your ancestors ate the world raw for millions of years. Giant guts, massive jaws, most of their life spent chewing just to stay alive. Then fire changed the deal. And the payoff is sitting in your skull right now, burning a fifth of everything you eat just to keep the lights on. The most expensive organ in the animal kingdom, paid for by the most important meal in history. And before that meal, before the fire, there were 2 million years of your ancestors eating the world cold and raw and surviving it. Just barely, just long enough for something better to come along.